Hi. We now turn to our third way to think about modeling individuals, and that's rule-based behavior. So in rule-based behavior, what you do is you just assume that people follow some rule. And when you're constructing your model, you say, here's the rule that people follow. So in the Schelling model, for instance, right, we just assume that people moved if the percentage of the people like them in their neighborhood fell below some threshold. That's a rule. Population below a threshold, you move. Standing ovation model, right, if the percentage of people standing is above a threshold, you stand up. That's another rule. So we can contrast rule-based behavior with rational behavior. Remember, in rational behavior, we assume people have an objective function, and then we optimize with respect to that objective function. We can also contrast it with behavioral models, where in behavioral models we assume that people have these sort of biases that they suffer from. Right? Now, of course, a bias could be a rule, and rational behavior could even be a rule. But when we think of rule-based behavior, what we really think of is writing down a rule and assuming people follow that. We look at 4 different types of rule-based behavior in a way, right? So we look at sort of fixed rule-based behavior, where we just assume you follow the same rule every day, right? And we can think about adaptive rule-based behavior, where you change your rule depending on sort of what's happening. So we can apply these 2 types of rules, fixed and adaptive, in 2 different contexts. So one context is a decision context, right? Remember, in this decision context, my payoff only depends on what I do. So the only person materially affected by my choice is me. And so I could have a fixed rule that I apply in a decision context, or I could constantly be learning. I could be adapting my rule over time. Second thing we'll consider is games, right? So in a game, that's a strategic context. Now my payoff depends on what other people do. And if my payoff depends on what other people do, it could be that I don't want to use a fixed rule, that I want to be a little bit more adaptive. But if I found one rule works well almost all the time, like in a bargaining situation, I may decide just to say I'm going to bid 10% less than my value. It could be that you just follow that fixed rule because you just think, look, it's worked for me in the past, I'm just going to stick with it. So what we want to do in this lecture is just walk through all 4 of these cases. That's the goal. We're going to walk through all 4 and just sort of get some understanding of what modeling rule-based behavior looks like. So let's get started. Let's start with fixed decision rules. What would be an example of a fixed decision rule? Well, one fixed decision rule that's actually used quite often is random choice. So I write down a model and I just assume that people choose randomly. Now, why would I do that? Well, the reason I do that is the same reason that Meyerson gave for choosing rational behavior. Remember, rational behavior is a really good benchmark. It sort of says, what would super smart people do in this situation? Well, we could also take the opposite benchmark and assume that people make completely random choices. And then we could compare the 2. We could say, well, how does optimal choice differ from random choice in terms of how the system behaves? And so by comparing those 2 sort of extreme points, we get a little bit more understanding of what might happen or what could happen. Now, that's sort of not what we normally think of as a fixed rule. Normally think of it as a fixed rule, it'd be something like take the most direct route. So for instance, suppose that I'm in a city and I'm right here and I'm going to head towards, I want to head to this museum up here. So here's this museum, put a little M next to it. And I come to this intersection and there's a road going this way and then there's a road heading off at an angle. Well, if I chose the most direct route rule, fixed rule, what I'd do is I would choose this one. Right? I would head in this direction. Now, it could have been, though, that if I'd have gone this way, I'd have found a diagonal street that headed directly to the museum. And it could be that this street goes up here and dead ends and I get stuck. So following the most direct route locally can be a good rule to follow, but it might be that there's something better to do. Okay? Now, the reason I give this example is because when we think of fixed rules, they may not be optimal. Right? They may be good, but they may not be optimal. So let's think about fixed strategies. Let's compare strategies to decision rules. Remember, in a strategy, my payoff depends on what other people do. So now, a strategy could be something like divide evenly. So let's suppose I'm in a bargaining situation, right? So we're thinking about, thinking about splitting an asset with someone. So for example, suppose that there's some land that, my brother and I have inherited, and we've got to decide, okay, how much do we get? There's 80 acres. Well, what we could say is, well, let's just divide it evenly. Let's each take 40 acres. That would be a strategy that I could use in a game, and it could be a fixed strategy. Now, we can have more sophisticated strategies. So a strategy that's described a lot is a strategy called tit for tat. So in tit for tat, you can imagine, let's suppose I can be nice or I can be mean. And let's suppose I start out in tit for tat by being nice. And I'll continue to be nice as long as you're nice. But if you're ever mean, then I'll be mean. But then as soon as you're nice again, I'll be nice. So I'm just going to sort of do unto you what you do to me. But I'll start out by being nice. Now, the reason I want to explain tit for tat is because I'll show you how you can sort of encode this in the context of a model. So you can use something called a Moore machine. And so this Moore machine works as follows. I'm going to put a little star here to say I'm going to start out by being nice. Now, what this green arrow says, this sort of describes what the other person's doing. So I'm going to stay nice unless the other person's mean. If the other person's mean, then I'm going to come over here and be mean. And I'm going to stay mean until the other person's nice. And if the other person's nice, I'm going to go back over here. So these arrows tell me if I change my state from the nice state to the mean state. So what I can construct is by writing on this little sort of computer program, I can take a behavior like tit for tat and embed it in a model. Now I can also embed another behavior, and this would be a behavior called grim trigger. Right? So here again, I'm going to start out by being nice, and here I'm going to stay nice until you do something mean, represented by the green arrow, and then if you do something mean, I go over here. But notice there's no arrows coming out of the mean box, right? This little mean circle, I just stay mean. So this is a strategy where I start out nice, but if you're ever mean to me, that's it. And this is formally called grim trigger. And the reason it's called grim trigger is that it's pretty grim, right? If you're ever mean to me, that's it, I'm mean forever. And the reason it's called trigger is because all it takes is one mean action on your part, and that triggers my perpetual meanness. Again, so what I'm showing you here is how you can write like just a simple diagram, write a computer model to represent rule-based behavior. So those are fixed rules, right? Now let's go to adaptive rules. What would an adaptive rule be? Well, let's suppose that you're, making, like I like to make chocolate chip cookies, or I make oatmeal chocolate chip cookies every week, and you're trying to figure out, okay, how do I make really good oatmeal chocolate chip cookies? Well, one approach that people sometimes use is called a gradient-based method. And so what a gradient-based method is you keep sort of trying things in directions that are working. So suppose I keep adding honey. Suppose I start out by adding 1/4 cup of honey, right? And it turns out that the cookies are pretty good. So then I add one tablespoon more. So I add one more tablespoon. So this is plus 1 tablespoon. So I add one more tablespoon, and it's even better. So then I might add another tablespoon. So then I might add plus 2 tablespoons, right? And so on. So gradient-based would say, if I find a hill, I keep trying to climb it. So that would be adaptive in the sense that instead of just following a fixed rule, I keep experimenting, trying to find things that are better. Another type of experimental rule is, let's go back, remember we talked about random behavior. It could be that I also try something completely random. Like I might throw wheat germ in, or I might throw raisins in, or I might throw walnuts in, I might do something just completely crazy. That's an approach, right? This random search, again, is adaptive. Instead of following a fixed rule, right, I keep changing what I'm doing, trying to find something better, trying to make a better decision. Now, where we see adaptation a lot more is in the context of strategies. The reason adaptive rules make more sense in the context of strategies is often the other person is changing their behavior to take advantage of me, so I want to change my behavior to respond to them. So in the context of a game, it's often important that you use an adaptive rule. So what would an adaptive rule be? So one would be best response. What does that mean? So let's suppose that we have some sort of strategic situation and the other person's taking some action. Well, what I could do is I could then think like a rational choice person. I could say, okay, what's the best possible response I could do given what the other person's doing? And I'm going to do that. Okay? So that's a rule I could follow, to just best respond to whatever the other person's doing. All right? What's another thing I could do? Well, mimicry. So one thing I could do in a game is I might not be able to figure out at all what to do, so I could just copy other people that are doing well. So I might look around and think, I'm not sure how to dress, or I'm not sure how to behave in this situation. I'm not sure how to bid in this auction. Well, what I could do is I could watch what are other people doing. I could just copy what they do. So those are two really standard ways. One is just to get the best response, try and think of the game, think of the situation, and figure out what's the best possible thing I could do. Right? But that's going to be adaptive because if the other people change what they're doing, the best possible thing to do next period could change. Another thing you could do is you could just do mimicry. You could look around and say who's doing well, and I could copy people who are doing well. A couple observations about rule-based behavior. First, sometimes optimal rules are simple. So sometimes you might have a situation like this where I'm trying to maximize my happiness. My happiness depends on two things, chocolate and movies. And here's my happiness function, right? It's the square root of chocolate times the square root of movies. And there's some price for chocolate and some price of movies. And I could sit down and think, okay, what's the optimal thing to do here? And if I actually solve for the optimal thing to do, it turns out I should spend equal amounts of money on chocolate and on movies. And so in some cases, the optimal thing to do is to follow a rule. And so assuming rule-based behavior isn't that crazy of a thing to do. You could just say, let's just assume people spend half their money on one thing and half their money on another thing. If I'm writing down a model of the macroeconomy, I might say, let's suppose that people spend 20% of their money on food, 30% on transportation, 40% on housing, and 10% on entertainment. Well, you may say, well, that's sort of a crazy fixed rule. Well, it's not, because if you actually wrote down some elaborate utility function and had people optimize, they do something that's fairly similar to that. But another thing, though, simple rules often can be exploited. So let me give an example. Suppose my rule is in bargaining, that instead of demanding half or asking for half, I say, look, initially I want 60%. And then what I do is I say, okay, next round I'll say I only want 59, 58, and I keep going down by 1% each period. Think about what somebody else could do if they're bargaining against me. When I say 60, they can say, well, how about 58? And then I can say, okay, well then I'll follow my rule, and I'm going to say 59. And then they could say, well, okay, 57. And I could say 58. And they could walk me all the way down until I was getting nothing, because they could just walk me down from 60 to 59 to 58 to 57 to 56 to 55 to so on. So a simple rule can often be exploited. So let's think then, let's give a quick summary. Why model people using rules? Well, the first one is it's often really easy to model, right? You can sort of say, here's my model, let's just assume, like in the Schelling model or in the standing ovation model, let's just assume people follow rules. It's computationally really easy to do, and it's easy to think through what's going to happen. Second reason, you can capture the main effects. Often if you sit down and think, how would someone behave in this situation, or how do I behave in this situation, you think it's just a rule, and you write down that rule, and you're going to capture the main things that are going on. Third thing, though, often it's going to be kind of ad hoc, right? So one of the problems in writing these things down is not everybody's the same as you. So remember we talked about the difficulty of modeling people. One is that people differ, and because people differ so much, any one rule you write down may be somewhat ad hoc, and it may not represent what's really going on. And then the last thing, which we just talked about, is sometimes these simple rules can be exploited. And so if you think about a strategic situation, writing down a fixed rule can be problematic, because if everybody followed that rule, other people would really take advantage of it. So where are we? We've talked about rational models of behavior where people optimize. We've talked about more behavioral models based on observation and even some recent neuroscience. And now we've talked about rule-based models. What we do is we sort of write down what people do as a rule, and then just ask sort of how does that rule aggregate. Depending on the situation, any one of these three things might make perfect sense, or maybe you want to do all three to try and get a deeper understanding of what's going on. What we're going to do in the next lecture is we're going to talk about how, in some cases, it's not going to matter very much what behavioral rule we write down. In other cases, it could matter a lot. All right, let's get started.